Hello and welcome. In this video I'm going to show you how we can use the chain rule for finding derivatives of functions. Before we start, let me remind you the chain rule. When we want to take derivative of any function, we have to take derivative of the outside function and then multiply it by derivative of the inside function. This is the chain rule in simple words. For example, consider this function y equals x over x plus 2 to the 5. This bracket here is the inside function. This bracket is the inside and the power 5 is the outside function. Based on the chain rule, for finding derivative of this function, first we have to find the derivative of the outside function. And the outside function is basically power 5, or we can think it as x to the 5. So we need to use the power rule to find the derivative of the outside function. What was the power rule? When we want to find the derivative of an expression based on the power rule, we bring the power in front. So 5 times, leave the inside and subtract by power by 1. So power 5 becomes 4. 5 minus 1 is 4. This is the only derivative of the outside function. Then multiply this by derivative of the inside. For finding derivative of x over x plus 2, we need to use quotient rule. We have a quotient, we have a fraction, so we need to use quotient rule for finding derivative of x over x plus 2. Let me remind you the quotient rule. If we have f over g, for finding derivative of f over g, this is the rule that we have. Take derivative of numerator, take derivative of f, multiply it by denominator, minus write the numerator, times it by derivative of denominator, all over denominator to the 2. This is quotient rule. Now we use this rule for finding derivative of x over x plus 2. Based on the quotient rule, first we have to find derivative of numerator, derivative of x. Attention, now here our focus is on the inside. Forget the power here. We want to find derivative of the inside. Derivative of numerator is 1 times by denominator minus, write the top function and then multiply by derivative of denominator. What is derivative of x plus 2? 1. Because derivative of x is 1 and derivative of 2 is 0, so derivative of denominator is just 1. All over denominator to the 2. And this is derivative of this function. If you want, for example, you can simplify the numerator of the fraction that here we have. Let me show you what happens if we simplify the numerator. Y prime equals 5 times x over x plus 2 to the 4 times by, this expression is x plus 2. Here we have minus x. X plus 2 minus x is just 2. So in numerator we only have 2, and in denominator we have x plus 2 all to the 2. So if you want, you can simplify your answer in this way. And also attention, for example, you can multiply this 5 here by this 2 and you can rewrite your answer in this form as well. This equals to x over x plus 2 all to the 4 times by 10. 5 times 2 is 10 over x plus 2 to the 2. And attention, we can rewrite this answer in this form as well. This power 4 is for x, is for basically numerator and denominator. So we can rewrite this as x to the 4 over x plus 2 to the 4 times by 10 over x plus 2 to the 2. Now Look at the denominator. X plus 2 to the 2 times x plus 2 to the 4 is x plus 2 to the 6. And numerator is 10x to the 4. But it's not necessary for you to do all of these simplifications. When you find the derivative, the only simplification that I think is good to do is to simplify this numerator and write it as 2. The rest of the simplification is basically optional. Now look at these two examples. We want to find derivative of the function e to the tangent theta and derivative of the function 2 to the power of x to the 3. These two functions are exponential functions. Let me remind you the formulas of derivatives of exponential functions. Derivative of e to the x is e to the x. The function e to the x is the only function that its derivative is itself. But when the base of the exponential function is not number e, in general, when we have b to the x, derivative of b to the x is b to the x ln of b. These are the two formulas that we have for derivative of exponential functions. But attention, here we don't have e to the x here, we have e to the power of something. Here we don't have a simple expression like x, we have a function, tangent theta. So we need to use chain rule for finding the derivative of e to the tangent theta. Based on this formula that we have for e to the x, the derivative of e to the tangent theta is also e to the tangent theta. This is the derivative of the outside function. So we have e to the tangent theta. But we know that based on the chain rule, we have to multiply this by the derivative of the inside. And inside here is basically the exponent. What is the derivative of tangent theta? The derivative of tangent theta is secant to the 2. So we have to multiply this by secant to the 2. And this completes this question. Now let me show you how we can find the derivative of 2 to the power of x to the 3. For finding the derivative of 2 to the x3, we use this formula. The derivative of 2 to the x to the 3 is 2 to the x3 times ln of 2. This is the derivative of the outside function. And multiply it by the derivative of inside. What is inside? The inside is the exponent, is this. What is the derivative of x to the 3? 3x to the 2. So multiply this by 3x to the 2. Let me show you another example. Here we have this function, x to the power of 100 times 100 to the x. It should be clear for you that here for finding the derivative of this function, we need to use product rule. If you attention, this function is the product of two functions, x to the 100 times 100 to the x. Attention, these two functions are fundamentally different. One of them is x to a power, the other one is a number to the power of x. X to the 100 is a polynomial, but 100 to the x is exponential functions. And the derivative of these two functions is different. For the derivative of x to the 100, you can use power rule, but for finding the derivative of 100 to the x, you can use this rule. 100 is basically b raised to the x. When we have 100 to the x, the derivative of 100 to the x is 100 to the x times ln of 100. So these two functions are different functions. And for finding the derivative of this function, we use the product rule. Let me remind you briefly the product rule. When we have f times g, and we want to find its derivative, We take derivative of the first function multiplied by the second function plus write the first function multiplied by the derivative of the second function. The first function is x to the 100. Derivative of x to the 100 is 100 x to the 99 times by the second function, which is 100 to the x, plus write the first function and multiply by derivative of the second function. Derivative of 100 to the x based on the derivative of exponential function is 100 to the x times ln of 100. Now look at this question. We want to find the derivative of the function e to the power of x sine of pi x. Again, let me remind you, the derivative of e to the x is e to the x. Whatever is inside the box goes here. Copy it here. But when here, instead of x, we have something other than x, any function, we have to multiply this by derivative of whatever is here. So we can memorize this formula in this way. When we have e to the power of something, derivative of e to any power is itself. Copy the same function. This is it, derivative of the outside, and then multiply it by derivative of the box, derivative of the exponent. Back to this question. We have e to the power of x sine of pi x. Based on derivative of exponential function, derivative of this function is e to the power of x sine of pi x. This is derivative of outside function, and multiply by derivative of the inside, derivative of whatever is here. For finding derivative of x times by sine of pi x, we use product rule. Attention again, this exponent is x times by sine of pi x. If you use product rule, derivative of x is 1 times by sine of pi x, which would be only sine of pi x, plus write the first function, which is x, times by derivative of sine. Derivative of sine is cosine pi x. But attention, when we find derivative of sine of pi x, derivative of sine is cosine. But remember, chain rule always. Multiplied by derivative of inside. This is inside of sine. Here, we took only derivative of the outside, but multiplied by derivative of the inside. What is derivative of pi x? Pi. So, don't forget to multiply this at the end by a pi. This is derivative of inside. And this completes the solution of this question. Now look at this question. The function f of x is e to the power of cosine of 3x plus cosine of e to the 3x. For finding derivative of e to the cosine 3x, we use this rule that here we have. Derivative of exponential function is itself times derivative of the exponent. So derivative of e to the cosine 3x is e to the power of cosine 3x times by derivative of exponent. What is derivative of cosine of 3x? Derivative of cosine is negative sine. But don't forget again to multiply it by derivative of inside. The cosine is outside, derivative of cosine is negative sine. Derivative of inside, derivative of 3x is 3. So multiply this by 3. So times this by 3. And now we have to find derivative of this. Here, the cosine is outside and the inside is exponential function e to the 3x. First, we have to find derivative of the outside function, derivative of cosine. What is derivative of cosine? Negative sine. So derivative of this function would be negative sine of e to the 3x. This is only derivative of the cosine, derivative of outside. Now multiply this by derivative of inside. What is derivative of e to the 3x? Derivative of exponential function e to the x is e to the x, e to the 3x is e to the 3x. But attention, here we have some inside function and its derivative is 3. And this completes the solution of this question. Let me rewrite my answer in a better form here. We have this 3 and this negative here. We can rewrite this in front. Negative 3 sine of 3x e to the cosine 3x. And also here we have minus 3, so minus 3 e to the 3x sine of e to the 3x. Now look at this function. G of x is given sine to the 3 of pi x to the 2 over 6. Whenever you have a trig function raised to a power, attention, here we have trig function sine and it is raised to the power of 3. I recommend you, at least at the beginning, which you are learning derivative rules, rewrite your function in power form in this way. Sine of pi x to the 2 over 6 all to the power of 3. This function is actually this function. We have to calculate sine of this and then we have to raise it to the 3. Why this form is better? Because when you rewrite the function in this form, it's more clear to you what is the outside function, what is the inside function. The bracket, the big bracket, is the inside and the power 3 is the outside function. Gradually that you get familiar with derivative rules, you don't need to do this anymore. But at the beginning, it's better to do this to not make mistakes. Now let's find derivative. First we have to find derivative of the outside function. The outside function is power 3 and we bring the power in front and we subtract the power by 1, so we have 3 sine pi x to the 2 over 6 all to the 2. Then we have to take derivative of the inside function, the bracket. Inside the bracket we have sine of pi x to the 2 over 6. Derivative of sine is cosine pi x to the 2 over 6. But don't forget to take derivative of the inside of the inside. Here this is outside. This expression is inside, but this is inside of this inside. So don't forget to multiply the answer by derivative of pi x to the 2 over 6. But what is derivative of pi x to the 2 over 6? Attention, derivative of x to the 2 is 2x. Pi and 6 here are just numbers. So when you want to find derivative of pi x to the 2 over 6, write the constant, keep the constant, and just take derivative of x to the 2. You don't need to use any product rule, any quotient rule. This is a very simple function. For example, how you take derivative of 5x to the 2? Are you using any product rule? No. You keep the 5, you take derivative of x to the 2, which is 2x, and you multiply that 2 by 5, you get 10x. Do same thing when you want to find derivative of pi x to the 2 over 6. Derivative of pi x to the 2 over 6 is pi over 6 times by 2x. Again, attention. All of this is a constant, is a number. When we have a constant, we write the constant and we take derivative of the function, the variable. So derivative of pi x to the 2 over 6 is pi over 6 times 2x. Now attention, the 2 in numerator and these 3 in numerator multiply by each other and they make a 6. 2 times 3 is 6. And we have a 6 in denominator here. We can cancel them and only in numerator we have this pi. So let me rewrite the answer again. We have only pi, this pi, times by x, pi x, times by cosine of pi x to the 2 over 6, times by sine to the 2 of pi x to the 2 over 6. I move the power from here on to the top of sign. And this is the derivative of this function. Now look at this example. Y equals a square root of x plus a square root of x plus a square root of x. Probably it's clear for you that you have to use the chain rule for finding the derivative of this function. This is inside of the radical. Radical is the outside and this expression is the inside. Probably you want to find the derivative of this function with rewriting this function in power form. So let me rewrite the function in the power form. We know that when we have a radical, we can write it as power 1/2. But after I finish it with this way, with rewriting in the power form, I will show you another way that is probably better than this method. But let's continue this for now. Now we want to find the derivative of these expressions, a bracket raised to the 1/2. For finding the derivative of this, first we have to find the derivative of the outside. We bring the power 1/2 to the front, and then we have this, the bracket, all to the power of 1/2 minus 1, which is -1/2. Then we have to multiply this by the derivative of inside. The derivative of x is 1. Now we have to focus on this. We have to find the derivative of radical x plus radical x. Let me rewrite radical x plus radical x here. Attention, you can rewrite this as x plus radical x to the power of 1/2. And now if we differentiate this expression, if we differentiate this, the derivative of this would be 1/2 x plus radical x to the -1/2. Don't forget, you have to multiply it by derivative of inside. This is the derivative of the power. We bring the power in front and we subtract the power by 1. But again, here we have to use chain rule. Derivative of inside. What is the derivative of x? So we have to multiply this by 1 plus, because the derivative of x is 1. What is the derivative of radical x? The derivative of radical x is 1/2 x to the -1/2. Probably you know this, because radical x is basically x to the 1/2 and its derivative is 1/2 x to the -1/2. So derivative of this expression here is this, so plus 1/2 x plus radical x all to the power of -1/2 times 1 plus x to the -1/2. And this is the derivative of this function. But let me show you another method for finding the derivative of this function. Not another method, actually it's the same method, but this is better compared to that method that we write every time radical in the power form. I recommend you to memorize this formula for derivative of radical functions. We will see radical functions repeatedly in calculus. So it's better to memorize this formula for derivative of radical functions. When we have radical of something, radical of any expression, derivative of a radical is 1/2 radical times by derivative of inside. So based on this formula, for example, when we have radical x plus 3, derivative of this is 1/2 radical x plus 3. And of course, don't forget to multiply by derivative of inside. This is derivative of inside. Derivative of inside, derivative of x is 1, derivative of 3 is 0. So derivative of inside is 1. So multiply this by 1, which you don't need to do that because it's 1. Now back to our question. We want to find the derivative of radical x plus radical x plus radical x. Based on this formula, derivative of this function is 1 over 2 the radical itself, the original question, times it by derivative of inside. So times by derivative of inside, derivative of x is 1 plus. Here again we have a radical, and we use this formula for finding derivative of that. Let me rewrite it here. We have radical x plus radical x, and we want to use this formula for derivative of that. Derivative of radical x plus radical x is 1 over 2 radical x plus radical x times by derivative of inside. What is derivative of inside? Derivative of x is 1, and derivative of radical x based on this new formula is 1 over 2 radical x. So we have to copy all of this here. So 1 over 2 radical x plus radical x times by 1 plus 1 over 2 radical x. If you attention this answer here and the answer that here we have, they are actually the same, but I prefer this answer because the given question is in the radical form, and our answer here is also in the radical form, and we don't need to convert back these power negatives to the radical form again. This is the benefit of memorizing this formula for derivative of radical functions. But if you want, you can only learn this method, and it's not necessary to learn this formula for derivative of radical functions. I hope you liked this video, and see you in the next videos.